Yo, hello guys, and welcome to another stream from Code Jam. Melody, what's up?
Hi Oliver, how's it been?
I'm good. I'm good. How are you?
I'm okay. It's been a rough week, so I'm excited about the weekend. What about for you?
why is why is that the weeks are just rough this period? Is it because of the weather, because of work, or
Generally for me, it's doing work. Like I've been, you won't believe this. I had my birthday on Tuesday, and I
Yeah.
didn't have the time to come out and celebrate. So
Happy birthday! Happy belated
that's
birthday! Yeah. So, yeah, actually, did not actually do anything. Like, you did not come out, like buy something, get something to eat, chill, or something like that.
I think I barely had time to eat on Tuesday, so I just was like, sometime
Okay.
around 6, I was like, oh, I haven't eaten today. Let me go get food, so I have to stay alive and do whatever I'm doing. So yeah,
Well,
but it's okay.
cool, cool. So today I just, during the week you'll just be, working, and so today I decided to just go out. I enjoy playing football, so I went out, but because of the rain, I was the only one in the pitch running around.
That's funny.
So, but anyways, the main purpose of going there was still achieved because I sweat, so like I get to exercise and stretch my body and all that. Yeah. So it was the week was cool for me as well.
Well, that's
So
nice.
yeah. So let's jump in. So today we're talking about, or we're discussing something really amazing, which is test-driven development. So everybody has their say on testing. I've worked with startups, and the way they front out testing sometimes it's like you're actually making them pay so much. Though testing is expensive, so but at the end of the day, it helps the software work, right? So that's just it.
Yeah, I think I've seen a couple of businesses who are like, uh, from a business endpoint, this is not really adding a business value. But if you
Yeah.
run probably a SaaS app or you run an application where security is very necessary, or where you
Yeah.
don't have to go back like 2 years from there and fix
Yeah.
every little bug, like type bugs and all that, things like
Yeah.
that, you need testing. Like I have experience working for an organization where you know there are just like every day we're having like simple bugs that could have been fixed with a proper test if they had
Yeah.
implemented a good test. So I think
Yeah.
testing is very critical.
So if you're running a company or you're a startup founder, would you you know be comfortable to would you be comfortable be paying extra time for testing? Like, because if a feature was supposed to be done in an hour, if you include testing, it'll be done in like 3 hours. So are you willing to pay for that extra time?
I think generally it depends on what I'm building. So if I'm building something very complex, yes, I am willing to invest that time and resource for testing. But if
So
I'm building something quite basic,
yeah,
like
are
a
you saying
basic,
that?
yeah, go
Yeah,
ahead.
yeah. Are you saying that what it depends? Testing depends on the complexity of whatever you're building.
Generally, from the way I see it, yes. If you're building a very static website,
Yeah,
where you're like, probably not very static, but something very simple, probably a simple code, you may not need testing in all the software. Like you're building a simple uh, come in, register, sign up for it, an email checklist or something like that.
yeah.
You may not need testing, especially in the front end. Uh,
Okay.
but I always encourage testing in the back end because the back end is the software, is the business logic and everything. So you need testing around
Well,
there.
I think testing should come in both because the front end is what users see and what it gives them a perception of what your software is like. Nobody knows what's going on in the back end. So I want to make sure that I have that when I click the button, I can log in and all that. So I think testing is actually important, like in every part of the software, like both the front end, the back end, and every other part that every other component you should want to test it because if you see once when a part is not functioning properly, the rest of it stops functioning properly. If the front end is not working well, the front end might be sending the wrong piece of data to the back end. All right. So, and if the back end is not functioning properly, the back end might be responding with the wrong response or something like that. So, testing is important at every level. That's what I think, though. So, if I'm to manage a project, as you said, definitely I would not want to be writing. To be real, I would not want to be writing tests for like a landing page or for a just like a dummy, but if I'm to
Yep.
build a real application with, expecting huge amount of users, and I have to write test because that project will definitely evolve. And to make that project, to keep that project safe and run and work as expected, we need to write tests. We need to have tests running and all that. So with me, as now when it comes down to, boils down to the developer itself, what do you think about testing? Like, what is it something you enjoy doing?
If I'm being frank, I don't enjoy testing because it takes a lot of time. It's very strenuous, and when you start dealing with test coverage and all that, there's this rationale around testing where general TDD has been misinterpreted, where people are trying to have a good coverage, a good test coverage, but and that requires writing your test after the code and stuff like that, which is a very bad one.
Okay.
Generally, I think I don't really enjoy writing tests, but it's something that I feel is necessary in a software. So
Yeah,
I feel more confident when I write tests. Like
yeah,
if I write a test for a code, I could go home and sleep, and
yeah,
probably I get a call from probably a teammate by somewhere out or something like that. Hey man, can we connect? And I'm not like, oh, did I break something or something like that, because I know
yeah,
I've run a test. My test has passed, and probably it's not something in my current deployment and stuff like that. So it gives me
yeah,
confidence, but the
yeah.
process is quite strenuous.
Yeah, same as me. That I think same applies to me. Like because I actually, to be honest with you, I don't really enjoy writing tests. Like enjoy it, all right. But at the end of the day, when I'm done writing tests, I have that confidence, and when you see all your test cases passing, it
Yeah,
gives you these good feelings, right? You build something and your test cases are all green and they're just going, and
yeah,
it gives you good feeling. But at the end of the day, still, I looked at it further and noticed that now the way you actually write your software, the way you act your implementation affects how easy it is for you to write tests for them. If your implementation is actually difficult, if you're not decoupling things, it will be difficult to test. And
yep,
if you find yourself in a way where you actually find it hard to test something, then just look at your implementation and try to see, okay, are there places where I could, instead of I could, add dependencies, like, or reduce dependency or decouple my code in a way where if somebody wants to test this, they could easily mock the methods or spy on them to easily test it. And also, one of the good reasons of TDD is that I mean, one thing you should consider when doing TDD or anything test driven is that you should ensure that your test cases are actually covering users' requirement. That is, they're actually correct, because you can have a test that you have good coverage, but what you're testing for is not actually what the user is doing with the application. So at the end of the day, the test is not as efficient as it should be. So when writing, you just have to pay good attention to your test cases, ensure you're testing functionalities, that is actual functionality a user can perform, and then with that, and ensure your code is decoupled and all that. So I think, no, I don't I've never seen it. I don't know, but I've never had a teammate that enjoys or find it really interesting writing tests. But at the end of the day, we noticed that having tests in the code base just gives that confidence and all that.
yeah. From what you said, I think it's very crucial testing for the correct instances or what the user wants or what the user
Yeah.
is going to use. For instance, imagine when you're writing a test, in some case where there is a core functionality, but you're writing a test and you're testing for a function, whether a function has been called or not. I think that's not really the purpose of that very test you want to write, right?
Okay.
You want to test for actual functionality, whether, let's say you want to test an addition, like there's an add number or something like that. You want to actually test that this number adds up to a certain value, right?
Okay.
You don't want to probably you could have it as a you could have a test case where you're testing whether that function has been called or not. But I think it's more crucial to test for the
Yeah.
user's requirements, as you
Yeah.
said.
Yeah. Exactly. So, discussed a bit about testing and what we think, our individual perspective about testing. So let's just jump in and look into the slide. So, yeah. Okay, so I'll be taking the slide, right?
Yeah, you could take this up.
Okay, so before we go in, I'll be taking the slide. We'll just be discussing the slides, and then we'll have a code demo session because we cannot talk what we don't do. So want to like show you that look, okay, this is some demonstrate what TDD is like, and from there we'll move on. I think from there definitely we'll wrap up. So
Yeah.
yeah, okay. So let me break down. Okay. Okay, so before we even talk about TDD, let's discuss something which is automated testing. When you hear automated, you think what comes to your mind is something being done not of human, that is not requiring human efforts, like just running on itself, like automated vehicles, automated to auto driving cars and all that. Okay, so automated testing, as the name implies, just testing is a testing. Okay, automated testing in software development involves using automated tools and scripts to test software application. Just think of it: test code, testing code. All right, you've written a piece of code. All right, you write scripts or another piece of code to test that code you've tested, like to criticize that code and be like, oh, are you actually running returning the right results? Are you actually um, making the right API calls? Are you actually hashing the values correctly? Right. So these automated scripts are actually doing what a user is supposed to do with that piece of code. Right. The benefit is that these automated scripts can be run anytime. You don't have to like, the product or the software doesn't need to get to the end user before seeing any bug. All right. The product can be tested even before getting to the user. All right. So automated testing just involves the use of code to test code, right? When it comes to testing,
Yep.
right? And the purpose of this is to, enhance efficiency. That's to provide efficiency because if you're having somebody manually testing your software every time, then the person will get bored of the job, all right? And also to provide reliability because you know that, oh, you have a CI/CD pipeline where your tests are being run before any deployment or before any code is being merged. Tests are being run, automated tests are being run to check that the software is still working or the new feature is still working and no breaking changes. Right. We also have quality. So the quality of your software is good that if a new feature is added, the user wouldn't even see anything like, bugs, right? So these are some benefits of automated testing. Okay, so the next one we have here is the testing pyramid. The testing pyramid just shows you levels of testing, like, from the unit test to integration test and to end-to-end, and then further to end-to-end test. All right, so when you look at it, with increasing altitude, like as you go up, you notice that the cost increases, cost of development increases. It's more costlier to do end-to-end test, less integration test, and it's even easier to do unit test. Okay, and also if you look at the pyramid, you notice that the test sizes think increases, test sizes increases, right? So yeah, all the way down, the test sizes increases. So this one is 10
Yeah.
to n plus 2. All right. So when you at the units level, you have more test cases because these test cases they run faster because you're just testing standalone functions and you're just testing standalone methods or classes and all that. Okay, so this is the testing pyramid, like from unit testing where you're testing code in isolation, right? And then you have the integration testing, where you're testing different components, right? You're testing, first of all, you're testing that the, let's say the card service is properly talking to the payment service, or you're testing that the payment service is properly talking to the payment gateway. All those stuffs involves different components. So that's integration testing for you. And also end-to-end testing, you're testing the flow from the user's end point of view. That is, you're going to be mimicking a user trying to use the application, right? So this involves something like synthetic testing, where you write scripts that automatically spins up Chrome browsers and try to
From
interact with the web page and all that.
Yep. I think
Yeah.
One example is when you're using like Puppeteer, and
Yeah.
sometimes you spin up Chromium and stuff like that to mimic button clicks and stuff like that. So the same way the user will interact with your software.
Yeah, yeah. So inside, yeah, exactly. So inside these test pyramids, there are other, different kinds of tests inside them. Like integration testing, you have something like performance test, you have something like stress test, you have something like load test. All right, you want to make sure that your, let's say before you make a new deployment to production, you want to make sure that the latency is not disturbed, or the performance of the application is still as it used to be. If your application was running at zero point 0.5 or 1 milliseconds, returning a response at 1 milliseconds, having a latency of 1 milliseconds, and then a new feature was introduced, and now you're getting that it's now, let's say, 5 seconds, then there must be a problem. What happened? We were running at this latency, and why is the latency increasing or something like that? So that's you can do that with performance test, or I think load test. Okay, I think performance test. Yeah, so that's it. So this is like this test pyramid, from the end-to-end test to the integration test to the unit test, and inside this of these test categories there are other kinds of tests. So today, with today's discussion, we'll be looking more into the unit test, which where we're going to be talking about TDD and all that. Okay, so we've talked about automated testing. We've talked about what automated testing is, that it's the use of scripts and all that, and we've discussed the test pyramid, which involves integrated test, end-to-end tests, the unit test, and the integrated test, that is integration, testing different components. Now, let's look into TDD. All right, TDD is actually a methodology. All right, it's actually a software methodology that emphasizing writing test cases before writing the actual code. When I first learned of TDD, it was a bit strange, because why will I want to test something I've not written code for? It was so hard. Then, then I was actually going through bootcamp, and the last bootcamp and all that, and they said, oh, this is how you have to do this. You have to actually write the test before you write any piece of code, and someone has to review the test cases and ensure that they are correct and they make sense, especially to the user, right? So that's the approach of TDD. TDD wants you to think of it like write code, or write your piece of code in a way that it's designed for actually the purpose it was meant to do, or designed for what it's meant to do, right? So when you first of all you write your test cases, you see that why trying to make those test cases pass, you actually be writing your code or that function to suit the purpose it's meant for. Okay, so that's the actual reason behind TDD. Okay, so we've learned that okay, TDD is a methodology that emphasizes writing test cases before the actual code. Right. So now next, let's look into um, the different aspect of TDD. That is what to do next. As it's like a circle. Okay. Okay. So before I continue, Melody, what's your experience with TDD? Like, how were you able to handle it at first?
So initially, the way I handled testing was, I have a piece of software and I have to write a test for it. But over time, I got to figure out that that is the wrong approach, because what happens is when you have a software and you have to write a test to pass it, you're trying to make your test fit your software, your already written software, because you don't want to go ahead and break anything. Or you're like,
Yeah.
oh, this software works, like, and stuff like that. But when your code is driven by your test, it means that there are a lot of things you do. For instance, you're going to do DI, right? Because you want to decouple a lot of things when you're doing unit testing. You don't want
Yeah.
one factor affecting the other. So you're going to do a lot of dependency injection,
Working.
at which, yeah,
Spying.
you're going to mock values and stuff like that, which is you're going to spy on something, so which is a very better approach to writing software. So by the end of the day, when you've written all your tests, you have a good understanding of what you want to do in the code, from the code perspective, right? And I think bigger companies, all these giant companies, what they do is they
Bang.
use the test-driven development. They have a test, then you're coming to pass those tests. Like you're coming to write a code, and your code should pass that test. right? And that is very beautiful, right?
Yeah, yeah, it is. But actually, it can be. I think when you're doing it, if it's something that you keep doing to become good at it, right?
Yep.
Imagine just sometimes there are some features to be real, like in the real world, there are some features that you yourself you've not figured out how to actually
Yeah.
implement it. You just want to start writing code, and if it
Yeah.
breaks, you amend the code and all that. I've been through that process, right? And now
Yeah.
when writing tests for it, like I don't know, like, am I going to use this package or this library? Will it work or something like that? So you're just in between. So it's to be real, like it can be difficult, right? But I think the more you keep doing it, the more you get good at it, right? You know how okay, you know that mentally you're already writing the code from the test cases.
Yeah, that's
Okay,
true.
yeah. So, okay, let's look at the first part of TDD, which is the red. So you can think of it like, write your test, So the red is the part where you get to write your test cases first. All right. So in this step, the developer writes a failing automated test that captures the intended behavior of a small piece of functionality. All right. That is the function. It could be a function, a class, or a method, right? The test is referred to as the red because it fails initially, right? So this point is crucial to TDD in that you have to write your test cases first. All right, so that's the first part, the red part, right? And once you write your test cases, you run them and ensure that it fails. Right? Once it fails, then you go over to the next part of TDD. Okay, so which is the green part. All right, so after writing and the tests are failing, the next part is the developer then writes the minimum amount of code necessary to make the failing test pass. All right, this is important because it prevents you from writing any form of redundant code. I've gone through some piece of code that some functions they are not actually useful when it comes to when you're thinking of it from the user's perspective. The user would never do something like this, or something like this will never come, right? I'm not saying that you shouldn't cater for edge cases, right? There are edge cases, but there are certain pieces of code that are just redundant, right? So now when you start writing your piece of code to cater for those test cases, now you see that you start to write your you start to add your implementation in a way that actually suits the user or meets the user's requirement, right? So now the code should fulfill the requirements of the test and achieve the desired functionality. When the test passes, it should be green. Okay. So the idea is after writing the test are failing, you then go and add your piece of code to make it pass. Right. You could do this a couple of times. You add a piece of code. You try to run the test, it might still fail. You update the code. You try to run the test, and once the test passes, then you can mark that functionality or that functionality as green. All right, and then we'll move over to the final part, which is the refactor. All right, your piece of code is passing, good, correct. All right, now they said after the test is passing, the developer can refactor the code to improve its structure, readability, and maintainability. Right, these steps ensures that the code remains clean and follows best practice. So you don't just want to make the test pass. You also want to since you have overall understanding of the code base, there are certain rules that are in place. Oh, don't use comments. Oh, don't um, always add logs. So that we know what's going on. Oh, okay, this is what you should do. Those rules. You need to refactor your code a bit, right? But you're actually not testing. You're not actually not changing the core implementation. You're just cleaning it up. All right. So cases where you're having extra spaces, you're removing it. Cases where you don't have to open a new curly braces like in JavaScript. You could just use a one-liner to make the code more readable. You could rename some functions. You could create some files just to make the code more readable. So this is the final part of TDD where you get to refactor things. All right, and the whole process begins again. All right, you want to add a new method or you want to add a new functionality. You start writing your test cases first, and then you begin to add implementation. All right, and you try to make the implementation pass test cases, and then you fractal. So this is TDD for you. Okay, this is test driven development. All right. So before we talk about the benefits, Melody, are there any things you could add to this, or are there any things that you feel could be strange or something like that?
Yeah, I think when you mentioned TDD requires you to write a minimum code that works, that passes your test. I
Yeah.
think I've seen cases where there are redundant code. Like I saw someone once write a
Yeah.
code, assigned a variable, then went ahead and did some if statements and reassigned that variable to itself. It was so redundant and doing nothing. And
Wow.
it
Well,
was
I
it
can
was
I cannot really imagine that.
yeah, it was so crazy. Like, and I've even seen like I have seen 2,000 lines of SQL statements,
Wow.
like just 2,000 line one call doing one thing, 2,000 lines of SQL statements with a bazillion of joins and stuff like that. So TDD really helps some of those cases, right? In those
Yeah.
cases, you see that okay, this is not necessary. When you've written your
Yeah.
minimum test or when you've written your minimum code, you see that it works, right?
Yeah.
Probably I just want to strengthen this, run an if check or something like that, but you don't go ahead and write things that are very really very redundant.
Yeah, yeah, absolutely correct. Yeah, so I think like you're correct with that. So I've had cases where I'm busy. I'm looking at a code written by someone else, and I'm busy, you know, wondering what's going on here. I'm trying to know what's this method doing in here. What's this? And you're scared. You wouldn't want to run the system. Like you wouldn't want to like break things by removing it. Just like that. You want to know what's actually doing before you remove it. Okay, so I think TDD helps us. Me too. I'm still learning. Like I'm still, every day we learn. So I'm still learning to prevent redundant code and always try to write tests depending on the project I'm working on. If there is already a testing framework.
Yep.
Okay, so now let's look at the benefits of TDD. We've discussed the benefits of automated tests, but automated test is a bit generic to every form of test. You could be testing a car, right? You could be testing a car using an automated script. So, but when it comes to TDD, now let's look at the benefit of TDD itself. All right. So TDD itself improves code quality. All right. TDD encourages developers to write focused, modular, and well-structured code. All right, writing tests first ensures that the code is designed to meet specific requirements and is less prone to defect. This is what we've been explaining with when it comes to TDD, meeting specific requirements and less prone to defect. Because when you think of it, the more code you have in a code base, the more difficult it is to maintain and the more costly it is to keep. And also, there are higher chances of bugs, right? When you start a project, most projects you start with just few lines of code, few files and all that. But as it grows, you begin to see that it's way difficult to maintain. Once you change the library and the whole system breaks, it takes you days to actually migrate or to fix the bug. So TDD helps improve code quality. And the next thing also helps with early bug detection. This is really important. All right. TDD catches bugs early in the development process as tests are written before the code. This prevents issues from propagating through the code base and becoming more challenging to fix later. That's another important aspect, early bug detection, and also faster debugging, continuous integration. So the benefit of TDD when it comes to continuous integration is just the final benefit of running tests, right? So when you include TDD in your CI/CD workflow, you see that the system is as if it's designed to control itself. That is, you don't have to be scared that my CI/CD should not go and deploy a failing software. It's getting tested before any form of deployment, or in fact, even when a PR is raised, automatically tests are run on those PRs even before your teammates starts reviewing them. So TDD helps with continuous integration and continuous delivery or deployment process. All right. It also provides higher confidence. I'm at peace when I know that my software, I have written tests for it, and the test cases are passing, and the test cases are specific to some requirements. Right. So these are the few benefits of TDD, even though we have so many other benefits of TDD. Okay, and what best practices first? You must consider edge cases when writing tests, write tests for them. As I said before, edge cases are important. you need to actually spend time in writing your test cases, in that your test cases should also consider edge cases, all right, so that you don't, mistakenly start allowing someone enter SQL through your forms, and the SQL is going directly to your database and running a delete statement or a drop.
Yeah.
Right. So I think that's called SQL injection. Okay.
Yeah.
So
I once
also,
did I once did
yeah,
a testing once for a DB, and
yeah,
I was able to, like, gain some admin permission, and lock out some users and stuff like that for a software
yeah.
via was it strange via stranger sent via the form and stuff like that. So it was very
Wow.
crazy. It's very crazy.
Wow.
I think most softwares now are, like,
Yeah, preventing it.
your libraries and stuff like that. They help to prevent that by
Yeah,
default. So
yeah,
for the most part, we are safe
yeah.
in 2023.
But they did not actually prevent object destruction. If you're writing JavaScript and you're doing object destruction at the back end without validating each object value,
Yeah,
you might start, especially when
that
you're
might,
using a database,
yeah.
you
Oh,
might
that's
start
crazy.
pushing in, whatever is getting sent from the
Yeah,
client. And that's one of the
something.
things, yeah.
Yeah, go ahead.
And that's one of the things I noticed since while working on the back end, you treat the front end or whoever is calling your API like the person is so like a dummy, right? The person doesn't know
Insane.
anything
Yeah,
about your API because if you think the person knows something about your API, this person could be you in future, actually
yeah,
sending the wrong request. All right.
yeah,
So you want to make sure that you're doing any form of validation correctly. So this thing happened to me, like, I was not doing validation at I had an endpoint where you could, do a CRUD. So I was just passing the object directly, using MongoDB. You don't have to, map classes, and
yeah.
a totally different kinds of build were just getting, populated on MongoDB. Was it that, oh, that's true? I was just, sending anything to the database. So yeah, so ensure you, consider edge cases.
I think they say in driving, when you're driving on the road, you consider the next person a mad person, and
Yeah, yeah,
that's something that applies to software engineering. Like when you're a back end engineer, you consider the
yeah.
front end person as, someone that hates you and wants to go after your job or life. So make sure you cover all parts and everything is safe.
Yeah, it's for the betterment. Like, it's actually for both of you, because if he does something wrong and the software is not working as expected, at the end of the day, they will question both the front end and the back end person. All right, you don't want to start sharing blames. You all want to take the responsibilities and all that.
Yeah,
Okay, so next we should also keep our tests fast and independent. When your test is fast, it's make deployment easier, especially for the DevOps guys. They don't want to. You're running tests for hours, and nobody will stand and looking at that. Even though those tests are being run on a CI server, right? It's costly, especially when you're using services like SQL CI. You're using something like GitHub Action. You're paying for the given number of time your test is running, right? So if you're writing your test cases, your test, ensure they are fast. By most times you want to mock some external dependencies that are not related to what you're testing. All right. So especially mocking some libraries, you might be mocking some hashing libraries that takes time to compute. Let's say you're using something like you're trying to do an MD5 hash, or you're trying to use something that does cryptography and all that. When running tests, I believe you must have already written test cases for the code that tests that the hash function is actually returning the right value. So when running a test for another function that depends on the hash function, you want to mock that part out, because if you don't, you're actually going to be running that hash function, which might increase the time, all right, needed for your test to run completely. So you want to make your test independent by first mocking. When you mock things, when you stop, you're actually going to make your test independent, because they're not depending on whatever library or package you're using for the implementation. And also, by making it less independent, your test is going to run fast, because less code means that the software should run faster, right? Less work to do. So keep your test fast and independent, and also start small and build incrementally. All right, that's actually some best practice you need to consider when doing TDD. TDD is a gradual process, right? If you come on board to a project, if you come on a project that does not have TDD and you're looking to implement TDD, you want to start small. Start from the from some part of the software and you want to gradually increment on that. Okay, so we've been talking about TDD, and said our different overview of what TDD is and how we've been feeling about TDD. Now it's time to do a workshop. All right. So
Yep.
Melody is going to take over this section and do a demo on TDD and apply TDD for us to see. So Melody, over to you.
All right, guys. Let's get over to the IDE. Is that an IDE or test editor or test editor?
Yeah, text it.
Yeah. So this is the previous code we had on our GraphQL. Is that is our inventory application where we
Yeah.
have a GraphQL setup and stuff like that. So what I've done is I've just modified this a bit. So if you go to the services here, I think no, that should be the resolvers. You're going to see that, well, I just added a bit of DI, nothing serious, just to get us running a better test. Because if you don't do this, then you're depending on certain values, and some values are like hard coded, and we don't want that, right? For instance, we want to
You
use a
might, you might,
different data source.
Melody, you might want to zoom
Yep.
in a bit because your fonts are a bit tiny, so you might want to zoom in.
How about now?
Let me just confirm. Uh, yeah, I think it's better now. We can work with this.
Okay, that's like all the way into my face. So
Yeah, that's the challenge of recording with a large
yeah.
monitor.
So you want to like have this data source, specify that when we are running a test, we want to run a different data source and stuff like that. And what we are just basically doing here, we are instantiating new instances of each service, because we want to like use each service as here, not instead of calling directly the repositories and stuff like that, we want to go ahead and call each service this way. So each instance of a service, we want to use it this way. You can see that initially we're like calling these services this way, but now we have an instance of each service and we are just doing a bit of DI. And let's go to the item service. So this is the one we'll be testing for today. So what we have here is a bit of DI, and here we have a decorator. This is coming from type DI, so you can go ahead and install that. Let's look at the package.json. You can see that we have a bit of dependency. We have the uh, type DI, which is the new thing, and we have the reflect metadata, which is like the two new packages being installed. And in our dev dependencies, we want to run uh, uh, our test. So I have you could install this type jest, and you could install this jest and ts jest, right? I think I just installed this, but I'm not really using it, so you could ignore this one for the now and go ahead and install the rest of them. So our resolver here, we are doing a bit of a same thing, sorry, this is our resolver. So we are doing a bit of a dependency ingestion, like the same way we've been doing it. We have you know, services here. We are trying to inject these services here, so we could have an instance of this tag service. I could use it, and this is kind of getting the connection from the constructor here, which is going to be called, which is like the first function that is executed when when your service is called, your class is called, or the first method. So that could be whatever you pass in to your data source here. And in this case here, what you'll be passing in to your data source is going to be, in a test environment, is going to be this connection here, and your regular environment is going to be a different data source. And there's no difference between these two. You can see here, the only different thing we are doing here is we are specifying a different database here. So that will be different database. And we are saying drop schema to be true here. And this means that we want to be able to drop, our schemas and everything. So each time we run a test, we're having a different, a fresh schema and everything created for us all the way from new, right? So let's write some tests. So
Yep.
we want to go here, and in our item service, we want to create an item.service.test.ts, right? So item.service, okay, dot test.ts. Now, when you have a dot test. So just since we are using just to just go ahead and look at where do we have this dot test or dot what's the
Spec.
name
Spec.
dot spec, and just is going to go ahead and consider that to be a test file, and just is going to run that for you. So a bunch of things we want to import. So we want to import the uh, type ORM repository, we want to import the item entity, the tag service, and the item service, because the tag service like is dependent on the items. Like uh, we are using the item tag service on the item service because there's a relationship. If you go to your schema here, you're going to see that an item has tags here, which is actually there. So we want to have that and stuff like that. So we could have every other thing, but these are the ones we want to have for the now. So I will go ahead and import this here. So we are importing the repository and all that. And now we can go ahead and create an instance or create, you know, should I say, initialize different services, right? So we want to type different services. So let's say let item service. Okay. I don't know why I'm typing like a snail today. And this is going to be of an item service. We want to let tag service to be of a type tag service, and we want to go ahead and uh, initialize an item repository. So let's item repository. Okay, is this? Thank God for you know is that Code Whisper. So we want to
Yeah.
have this item repository this way, and we want to equally have a connection. So let connection. This is going to be our database connection, right? We want to have this to be, all these are very empty right now. So we want to have this way as well. So we want to run a code. So before all or before any of these tests is run, we want to go ahead and have certain things set up for us. So we are going to run a before all, and I think this is you can have before all. Before all is something you run basically before any of your tests run for this file. So before all, have this way and this. So before all, we want to have a connection. We want to assign the connection to await. We want to await a connection and want to use this test, create test connection. So before any of our test runs, we want to have a test connection, right? And we want to initialize that. Dot initialize, right? That's the same way. That's the same thing where if you go to your index.js
Melody.
here, yes,
Yeah,
please.
Melody. We're getting some feedback when you type. We're getting some sound coming out. I don't know. Is that from your keyboard?
I think it's from my system. Let me see. Let me see if I can uh, halt the sound. So let me see sound. Give me a sec.
Like when you, I think when you hit the keyboard, I don't know what part of the keyboard, but it makes it sound.
Yeah, it does. So I think I'll just. Hmm. I think my system has a VS Code sound activated. I don't know how to deactivate that right now. But every
Okay,
time I
okay,
make a mistake or something like that, the sound pops up. Uh,
okay. What if you like deactivate the extension? Do you know the extension causing that?
I don't think it's an extension. I think somewhere. Okay. Uh, nope. I just can't do nothing
Okay,
about
let's
that.
continue.
All right. I think I'll just. Okay. Cool. So we want to go ahead and initialize this, and this is the same way. This same thing we're doing here. So nothing too fancy. We are going ahead to initialize that data source before we run anything in our code. Uh, then we want to go ahead and connect our tag service and our item service to the connection. So if you see here, if you come to our resolver here, uh, I think, yeah, our resolver here, you're going to see that this text service is accepting, you know, is accepting a data source which we are injecting into it and stuff like that. So we want to go ahead and do something similar to this in our code. So we are going to go ahead and copy this, come back here and do this. So remember, we already have our text service all initialized here. So what we'll just do is, reassign it to this here. And I think this should be having a connection. So this should have a connection. Oh, this is annoying. Sorry about that, guys. And this is our tax service. So we want to have this way. And finally, we want to have our item repository. So we want to assign our item repository to the connection repository, right? So we'll say item repository equals connection dot get repository. I want to pass in the item this way. And after that, so after all, so after the test runs, we want to go ahead and destroy that connection because each time we run our test, we want to have a different connection. So say after all, we want to go ahead and destroy that connection. So this is not fancy or there's no difficult thing here. We just want to say connection dot destroy.
Close. Okay,
Yeah.
destroy.
Yeah. I think close was type RM has changed a lot. Initially it was connection dot close, but after a while they changed a lot of things like the data
Yeah,
source was
the
introduced and
data
stuff like
source
that.
API.
Yeah, was introduced and a lot of things were changed. So let's write our test. So we want to describe our test. So let's describe, wow, this code is very smart. This code whisperer is very smart. So we're going to use this. So we want to describe our item service and yeah. So describe block is like, okay, it's just like more like for visibility's sake. This is where our item service runs and all that, right? So first we want to check that we want to write check that when we call and get items it returns an array of items, right? So let's do that. So when we call repository dot get items it should return an array of items. So let's describe it and say should return an array of items
So this is
when
you writing the test cases now, right? This is you
yeah.
adding test cases.
Yeah, this is me writing the test cases.
Okay.
Right? An array of items, okay, should return an array of items when get item is called. Right? Then we want to go ahead and do this. This is weird. So now, first thing we want to do is want to mock the item we are going to like feed into you know like we want to get, right? Because right now we've not created any item to be able to see an item in our database, right? There's nothing in our database at all. So we want to go ahead and mock that items, right? That's going to be in the database. So the way we do that is let's mock some values here. So I'm going to go ahead and grab some mock values here. And this is nothing fancy. So we are mocking some values here. Let me explain this. So what this does is we are initializing a constant of an mock items, and we are saying that this is of a type items. And if you see the type items here, it's the type RM class, and we are saying that the ID for this one is one, item is one, image is empty, tags is an empty, description, created art should be new dates, right? So new dates, and the same thing we have another one. We have a couple of them. We could have another one, probably three. We have another one here. Say something like this. We want to say this is three and this is three, right? And now, currently, we don't have, we don't have, we don't have, we want to run a unit, like we want to mock our find method because we are going to using our find, right? Find method to find values, right? So we could run a just spy on the find method of the item repository, right? So we'll say just dot spy on. I want to spy on this, which is very beautiful. So this is so we are spying on this here. So more items. Is there something I'm missing here? So
You want to
dot.
spy on the find method,
So this should be uh
mock return value, isn't
mock
it?
result values, right?
Return value.
Mock result values.
Okay. I
Yeah,
thought it's
mock.
mock return value. Okay, mock
Okay.
result value. Okay.
Yeah, mock result values. So we are mocking the result values. So what this does is this is going to mock this find method on this item repository here, right?
Yeah.
And we are passing these items here. So whenever we call the find method, right, it's going to feed in this and use it to return to the user, right? That way, we are not directly calling our data, like we are not needing to have values in our database or create an item service for us and stuff like that. And the reason this is a unit test is because if if in a regular case, what we need to do is we need to create an item in database first. So this very test suite is going to be dependent on whether an item is existing in the database or it's not existing. But we don't want that. We want a situation where, well, this test should not care about any other thing, right? We want to provide some mock values. In this case, say we have some values in the database, say those values are these, right? Am I expecting that the function I'm going to call is going to return these values? That is what we want to say here. So the way we do that, we'll go ahead and say, uh, so we want to go ahead and say the items, right? So we want to initialize a constant const items. So the items that we are going to get, we are going to call the await item service dot get items, because now this item service should have a get item method that when it's called, whenever we call the get item method, it should return whatever is in the database, right? And this currently does not exist. If you look at the item service, we've not written any value yet, but there's a get item here. So what we're expecting is when I call these get items, go ahead and return some values for me, right? And we are getting this value now. We want to run our actual test. We want to test this value. So whatever is coming here, I'm expecting that this value, expect that items is equals to this more items. This is one of our test expectation here.
Yeah.
So we could equally expect that this value, this whatever, we could expect some other things. We could check that the
It's an
first item
array.
is, yeah, it's an array. So we could say expect uh, items dot uh, that is an array, right?
Yeah, it's
Yes,
array.
is array is array. Nope,
No, what's that method called?
I have forgotten.
Just add a dot. We should see it when you add a dot.
Okay,
Is there a
so
type of there?
to be called, to close, to be falsy. Nope, to be
Dot length.
truthy.
Okay, you can use dot length. You can use items dot length to be greater than items dot
Okay,
length to uh
have to have lengths.
yeah, to have length. Can you still use
Okay,
to have length?
so
Uh
have length
should
of
be,
3.
yeah, since you have three items, but that doesn't actually check if it's an array. Okay, so you
If
can use item dot length not to be undefined. I think I've
okay,
items dot
items
length dot
dot
length. No, items inside items dot length. No, only array has the length property in JavaScript.
okay, the actual items
Yeah,
dot length, but not to be undefined.
yeah, not dot, not dot undefined. I think not
Mm-hmm.
not there is a not at the top. You passed it.
Not okay. Not
No, yeah,
dots.
undefined
Uh,
or to be undefined or something.
mhm. Okay, to be undefined. Here it
Yeah,
goes. And
the not is a method or a function.
yep, the not is a function.
Yeah.
No, I don't think it is.
Okay, it's not okay, just remove the function. So why is it having squiggle line? Okay.
So it's saying this property length does not exist on is okay. Property length
Yeah,
does
that was
not
because of the
exist.
typings.
Yeah, the
What's
type
types of items?
item does not have this coming from item service. Yeah.
Okay, so you just have it as maybe have it as any since it's returning void actually.
Okay. So I should just make this an any here.
No, 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 no. Like where you have items, the assignment where you assigned it items.
Okay, as any.
Online 30, online 35.
So I should make this as any.
Yeah. So after during refactor, which is the last process, blue, you just clean up those type checks,
Okay.
like perfect the type checks. Yep.
Could equally make it as a type of items array or something like that. Probably here items uh item array.
Okay, that works. But it's an error because that function or that function that method because it's inside the class,
Yeah.
like so that method does not yeah return a value. So
All right. So this is the basic test we have. So we have a couple of tests. We have uh, this and this and this. Now, if we go ahead and run this, so let's go ahead and run it. So I'm going to bring this down, and I'm going to say just. So here we have in here we have in our source here we have or scripts here we have uh, tests. So if we go ahead and run npm test, going to run Jest, and Jest is going to find everything that has it dot test and run it. So if I run this right now, it's going to fail.
it
Okay,
passed.
so
Did anyone pass?
hmm, I let's see. Okay, this is to equal this. Okay, so what we have here is not to be undefined. So I think this is not undefined,
Okay.
right? This is not undefined. So we
No,
have
I think the
syntax.
test case passed. If you scroll up,
Yeah, test case passed. Expected
yeah,
this,
the
but
resolver,
undefined.
the test on inside resolver.test.js. There's a test somewhere, resolver.test.js. So you can search
Okay.
resolver.test.js.
Oh, that's true. That's true. We have a
I think
resolver
it's an
that.
older test.
Yep, I think so. So let's see. Uh, resolver, resolver. There is no test. I had a test, a couple of experimentation for resolver.test.js.
So inside services, inside GraphQL, source
There is
GraphQL. Okay, where is
there
he picking up
was
that test from?
that's funny. There was a
Okay, you
test
need to
here.
rebuild your project. So I think your test script should actually build first before.
Yeah, yeah, that's
Can you
true.
clear your dist? It's considering the dist and it's not ignoring your dist folder. So just rmrf your dist folder
Okay, so
and
we
then
want
run
to
it
build
again.
this
No, you don't have to
auto.
build. You just run it again.
Okay, it's going to auto compile.
It's not going to. It doesn't. I don't think it
So
needs
it's going to
compile.
run. Yeah, generally going to run the.
Yeah.
Oh,
So that's
cool. So, so I think it was running the this folder
yeah. It was
initially.
including the dist folder.
Yeah. Okay, so we have a test here that is failing, and this is expect this to equal. No, this test case is failing here, and it's pointing it out. So we have one field,
Yeah,
one total. Okay,
which is
so let's
good.
go ahead and make it pass, right?
Yeah, so we've just first of all we've written our test case, Actually, in the real world, since it's a demo, we're just writing one. In the real world, you have to write plenty of test cases. Even though you're testing a single function, you write different test cases for it, and then you go over to have those functions implement pass those cases one after the other. Okay,
Yep.
so now we're going into
Let's
the next phase, which is yeah,
Okay. We could equally
yeah,
write another test if probably if when we've added this, we could just write another test and see, just to get an idea of the whole thing. So uh
okay.
let's go to
So
our
we could add
items.
all the tests we need, like maybe extra one more test case,
Okay.
right?
Yeah, let's add one more test. So let's say uh let's get the get item by ID. So if you come here, we have this. So we have the second one, which is get item by ID. Want to
Yeah.
see that when you supply this, well, it should be this should be called with a valid ID and stuff like that. So return an item with a valid ID that shows. So if you call this with a one, right, it should return that item with a valid ID. And yeah, so let's go ahead and test that. Or should return that
Yeah.
very item that we called it with. So
That matches the
let's go.
ID.
Yeah, sure. That matches the ID we called it with. So let's go ahead and do that here. So I'm going to copy this because laziness is a nice way to live a life. So, uh, so let's say should return an item when get item by ID is called with an ID. So, or should return valid item. Should return a valid item
Okay.
when get item by ID is called with this. So we want to go ahead and remove this is not going to be an array. So our mock item is going to be of a type item, just one simple item, because we
Okay.
want to simulate one single item here. And we could remove these ones, right?
Okay.
So here we
That's an
have,
object.
yeah, these are an object. So we could remove this as well. So we want to spy on the find one. I think find one by, right? Find
Okay. By ID.
by ID. So we want to mark the result value, passing the this, and we want to say that the item, yeah, we are waiting the item service dot get item by ID, which is this. When we call this service, we want to get this.
Okay.
So and this accepts an ID. So dot get this. This accepts an ID, and that ID is going to since we are having a one here, we want to check that
Yeah.
that ID is actually one, right?
Yeah. And also you need to rename the variable on line 50. It's no longer items but item.
Yeah, sure, item. So we want to make sure that we are expecting that this item here is going to be whatever item is returned is going to be
Yeah.
equal to the mock item value here. So this is correct. Want to check that the next we could have another test to probably know.
Another assert statement. Yeah.
So I think this works for the now. So let's go ahead and we could have some other test expectation. So we could expect that this should be truthy or ever, all that stuff, or that it's not undefined and stuff like that. So, but this is just a basic test. Uh, yeah, and let's run it again. Let's run our code and see that two test cases are failing. So I'm going to clear this and I'm going to run npm test. And if we have everything right, two test cases should fail. Good. We have two test cases failing and one test suit failing here, which is the describe block
File.
here.
Yeah.
Yeah.
That block.
So let's put in some values here and see that this is now passing as it's supposed to. So let's go to the item service.
So we're going to the green phase now.
Yeah.
Or rather
So
trying to make the green phase possible.
sure. So
Okay.
here, instead of returning an empty here, we want to go ahead and return the item So we want to say we okay, you know what? Let's call this a constant const items equals we want to say await items await this the repository defined, right? Because we marked the find value, right?
Yeah.
So the item repository which has been injected here, right? We are calling this here and we are finding. So whatever comes through, just go ahead and return that for us. So return the items here for us. Let's save that. Would this work? Well, let's see. So let's go ahead and run this test suite and see if it passes for us, right?
Yeah.
Okay. So run this. Go. So you can see that this one is passing here for us. So this first one is passing here for us. Should return an array of items when item is called is passing for us, and that is because in a it's just self-explanatory. We have a repository find method. Whatever it finds, just go ahead and grab that. And in our test case here, what we are doing is basically we are mocking that find repository method here. So we have a repository method here, which is in our describe in our before each block, connecting to our test connection here, and we are passing these items here, right? This item, or should I say this entity here, right? So it's aware of the schema, this the structure of this item entity here. And what we are doing is we are mocking the type rm find method here, and we are resolving the value with this mock value. So we are saying that, well, I don't want to save a value in the database, but whenever this method is called, when a find method is called, which this does, right? This item service is actually calling this guest item here, is actually calling the find method here, which you can see here. It's calling the await repository.find. So whenever that is called, go ahead and resolve that value with this value here, right? So that is what it's doing, is resolving that. And in our check here, we are seeing that, well, we want to check that this item is equal to wherever this value we are passing here, like this mock value here. Secondly, we want to check that this value is not undefined, and we equally want to check that the value is having of a length 3, right? There are 3 lengths here. We don't want an extra value or an extra item or something like that. And every time I call this is going to give me the same result. This is going to give me the same result, and it's going to give me the same result because after
Yeah.
everything, I'm destroying this connection and stuff like that. By the ways, we are not even saving anything in database, so we are mocking all these values. So I think even though we don't destroy this connection here, it should still work for us. What do you think, Oliver? Do you think it's
Yeah,
still
it's
going to?
it's still it still works because in fact that's actually something I would love to. I love that we're sharing this because when you mock things, your code is no longer the test is not depending on something to pass, right? So it's not depending on database. Somebody could come change the database and remove something, or your previous test might even modify values in the database. So you want to make sure you're mocking all the values so that at no matter number of times you run that test, you're still getting the expected results. Yep.
Definitely, definitely. So you can see here, you just remove this connection destroy here. We are mocking every value here. So every time you run this value, your values are going to depend on your mock value.
Yes.
So the reason we, one of the reasons we are doing this mock value is, well, I don't want to rely on my database. My database could nuke at some point, right? Something could go wrong in my DB. I am not testing for my database. I want to test my software that is actually going to work. So if database is correct, if connections and permissions and everything are allowed in the database, my code should work. And this is what this unit test is doing here. So we have this one here. So let's go ahead and add the second one, which is the get item by ID. So we have this here. Instead of returning nothing, we want to call a constant item from our test, because this is driven by our test. You can see that uh, we are marking the find one by. So we want to definitely get the repository and find one by the ID. So that's what we are
Okay.
going to do here. So we want to say await this the repository to find one by, and we are finding one by the ID here, right? Did I do
Curly
something wrong?
braces, curly braces. You missed the curly braces went off by the autocomplete. Yep.
Okay. So, and we want to go ahead and return that. So we are finding one by the ID here. which is the value we marked, and we want to go ahead and return this here. So I'm going to save this. And with this, I think our test should pass for the second time. What do you think? So let's run it.
Uh, let's look at our test cases one more time and see maybe.
Okay. Yeah.
Uh,
So
yeah, I think so. Find one,
yeah,
mark result value item, get one. Yep.
cool. So let's try it. So we are going to run an npm tests, and this will run, and we'll
Yep.
have our two tests passing for us, which is very beautiful, right?
Yeah.
So I think this is the general concepts around the writing tests, unit tests, and stuff like that. And you could do a little bit of a integration testing where you're testing different components. You're testing the interaction of different components and stuff like that. And I think doing an integration testing will require you to write a lot of uh, tests, like probably an entire test, because you're going to be testing those services, and you want to write a test for instance, the tax service. You want to write a test for the tax service and all those things here, right?
Yeah. Yeah,
Cool.
so I think we're done with the green section. So now we do the refactor, which is the blue. So are there piece of code you think we could make it but better, or could places you think we could clean up, like the any
Yeah,
the as any.
yeah. The as any. Let's see how we could clean this up. So
It just works because now it returns the right value. TypeScript is seeing that, look, oh, okay, you've implemented this method, right?
yeah, so it's
Cool.
in here. The promise of items is actually returning the right value. So we don't need that value no more, and this
Yeah.
as well. We don't need that value no more. So when we remove this, our test should still pass for us, which is one cleanup.
So we're done with the blue.
It still works for
Yes.
us. Very nice. And this one here as well, this destroy connection. For this test case, we don't need to destroy a connection. Uh, we could if we are actually creating values or something, but here we are mocking all values. So we
Yeah.
probably do not need this, but I think we could leave it for the now. Or do you think we should take it out?
I think we actually can even comment the connection initialization as well as the connection creation, because we're mocking all the methods from time this thing type RM depending. So
Okay,
let's just check it. So just comment the connections. Are you using the
okay.
connections somewhere else? Yes. So just comments the connections.
I think we're injecting that connection here, right?
Oh, that's true to the
So we
service.
need that connection, but destroying the connection, we don't need it here.
Well, we might still need it, because when you destroy the connection, like you don't want your test opening up several
Yeah,
connections to the database. There could be other tests. So you want to make sure you're destroying the connection once the test is done, right? Once you're done
yeah,
with the
definitely.
test.
Yeah,
Yeah.
definitely.
So
So I think that's it for these test cases and stuff like that. So do we have any questions from our audience?
I think none for now. So that's I think we're good.
Cool. So
Yeah.
guys, that should be it for this jam. Suspend Jam, we are going to be bringing something very interesting to CodeJam streams. We have something down the pipeline, which is very big, and Oliver and I were kind of discussing on it and having this, general, looking at how we could make it more of a reality. I think it's two or three jams down the pipeline, and it's going to be very big and very huge. So we want to
Yeah.
really get it right. And I'm super excited about it because this is something like that intrigues me, and it's something that you're going to face in the real world. Like generally, everything we do on CodeJam is something you're going to face in the real world. Like
Yeah.
if you are being very realistic, right? But we could have probably spun up a simple node application and probably written a test for an add function and say this is equal this, but we wanted to use something that references something we've already built. So you have that feel of, okay, I've written a software or I want to write a software. How do I go about it and stuff like that? How do I mark values and all those things? So with this, we believe people who are probably not very used to the testing world are going to expand their knowledge on tests and use this as reference and stuff like that.
Yeah, super cool, super cool. Like I enjoy this section. Even me myself, like I'll get to like think of test more. And we encourage you all to subscribe. I think it helps encourages us to like keep creating something like this. If you like this, just subscribe. And we've got so much like in the pipeline where working on improving, bringing in more contents and all that. So I'm really excited to be here, and I think that's it. Melody, any final closing remark?
I think my closing remark would be subscribe to our code jam, right? We need this a lot. Go ahead and subscribe.
Yeah,
Turn on the notification so you get notified every time we go live. Like it really
yeah,
helps us when you subscribe and you could
yeah,
like our videos when you find them very helpful. That way we know that we're headed the right path. You could equally give feedbacks. That way we know what you want and how we could provide that to you.
yeah, yeah. Okay,
All right.
thank you guys.
All right,
Bye
guys. Take care.
bye.
Bye.